Howdy, I'd like to talk about making cutters. Now I've toyed around a little bit with making some cutters for clock wheels and pinions, and I've come to a certain conclusion about how I want to go about making my cutters. The reason I want to make my own cutters is I do a lot of clock repair, and often I need to cut a wheel or a pinion for a particular clock. Most times I have the original part. It just needs to be restored or remade. So the other thing that's got me into this, well, a couple other things, is that I'm wanting to build my own clock movement from scratch. And I know you can buy commercial made cutters, but they do get rather expensive. One of the places I know of is Thornton. The other thing is that if I needed a certain cutter for a particular job and I didn't have one, it may take some time in order to get a commercial made cutter sent to the shop here. So I decided to try to teach myself how to make these here multi-tooth cutters for wheels and pinions. What I initially did is I started out with research, of course. A lot of books that have information on the having the math involved in determining gear ratios and things like that, and other books with some more involved ways of making cutters. This is Donald D. Carl. He's got some information in here. Good book for clock repair. I have The Watchmaker's Lathe by Ward Goodrich. He has a section in here on making some cutters. What he's doing here is he's cutting a slot underneath the tooth or the form of the cutter tooth and then bending it, which will give you your reliefs, which is an interesting idea. I may practice, or I may experiment with fly cutters, of course. There are several different techniques in making different fly cutters. Book here from Malcolm Wild. Whoops, sorry. Malcolm Wild, Wheel and Pinion Cutting in Horology. Excellent book. He's got info on making fly cutters, the different modules, different styles of fly cutters, some techniques in making them, and then he comes into an area where you can make these multi-tooth cutters. One tool he does use is called the this apparatus here is called the Eureka Tool, and that does your form relieving on your tooth form. But I struggled a little bit with that because, let's see, because once you make your cutter blank and get your form on your tooth form on your cutter, you use this tool to back cut that, or make the relief cuts. Now my only struggle with that is you use these different parts. You would have to have a multiple of buttons to get the right radiuses, and different radial flank angles that you might have to be concerned about. Things like that. Maybe I'm not understanding the tool fully, but plus they're hard to find. I guess, and I've read a little bit about them, the ones that have been manufactured, not being the best. So, but it's a neat concept. Maybe someday I'll look into that. What I did find was a book by Robert Porter, The Clock and Watch Maker's Guide to Gear Making. This book gets into making cutters with simple tools, some other tools that you can build. For instance, a sine bar attachment for your slide rest, which I've made one of these, and later in another video I will go into a little more detail about how that functions and what mine looks like. But instead of worrying about, I think you would call it back rake and all that, what he's doing is offsetting his slitting saw, which you may be doing in the other ones, and cutting this behind the center so that when the cutter comes around, it scoops the material out. Now the top side of these cutters is still in the full radius of the form, and it may not give quite as nice a cutting action as one that's been form relieved. But I have made a few of them as experiments. You'll notice all these are different size arbor holes and things like that, different tooth forms. My very first one was just to get some ideas on the concepts and making one. Now my knowledge in this subject is building at this time, so by no means would I imply I'm an expert in this field of making these or doing this. So an experiment I did do was I took wheel and pinion out of a existing clock. We have the wheel and the pinion, and with this particular book, if you can see this sheet with all these numbers on it, I'm moving it around a little bit. In that particular book, he has cheat sheets, so to speak. Here, I'll show you one here. We get back here. Let's see if you can see that. Watch and clock gear set and cutter quick reference sheet is what he calls them, quick reference sheets. So if you have a particular wheel and pinion, you could do the math. He's already got most of the information in here. You just plug in the numbers, and you can figure all this out with a calculator and so on. So what I did in my experiment was I took a wheel and a pinion and just wanted to use two numbers to see if these cutters would turn out right for me. The two numbers I needed were center distance here, the number of leaves on the pinion, and teeth on the wheel. So with those two numbers, center distance and the number of divisions I needed in that particular circle, I started plugging in the information. Without checking as I went, I produced a couple of cutters here. I believe it's these two. I can't remember. Well, it's two of these anyway. One I used for the pinion and one I used for the wheel. Made a wheel, cut a wheel, and then I cut a pinion and depthed it in my depthing tool, matched it to the original to see how close it was, and it was really close. It was so close that I think the only difference I ended up with in using these formulas was that my tooth form ended up being more cycloidal. I don't know if that makes sense, but from what I understand, over the years there could be different tooth forms implied in their cutters, depending on the age of the clock. And of course, before we had milling machines and things like that, a lot of this was, well, all of it was done by hand. You had a master template and you may have cut the slots and then gone over the tooth to give it its cycloidal form with a file and round over that tip of the tooth, the addendum of the tooth. And this, I'm not sure about pinions, but probably the same type of work would be done, filed out by hand. So my experiment with this, actually, it worked out rather well. I was really pleased with it. And so what I'm going to do here is, hopefully I can show you guys how I'm going about it and some of my reasons why. We'll go from blank steel to actual cutter. I'm going to try, instead of eight teeth in my cutters, I'm going to go back to a 12 tooth cutter. And then we'll experiment with, we'll just plow it into some steel and see how the cutter performs, what kind of shape it's given, and so on. And then we'll cut some brass afterwards and see if it holds up. It appears these are holding up just fine, even though there is no relief cut in the top of these teeth. It's staying sharp, and all these have gone through some steel of some sort. I also made an arbor here, and this arbor I made to hold my cutter, which I changed my dimensions in here a little bit, so none of these cutters will fit on this arbor. But this arbor I made to fit in my Schablin 70 lathe into a collet, and then in my milling machine it'll fit into the corresponding collet. So that'll allow me to move it from one tool to another and keep it pretty close in tolerance. I also had made this a little longer here, right in this area, to accommodate how I'm going to set up for forming these cutters. And I also wanted length on the tail side of it here, so that I could support it with my tailstock, yet kind of keep my tailstock out of the way. It's a little tight. So this is a 1/4 inch hole, it won't fit on there. And then these are, I can't remember what these are, 3/8 or something. But so I made a 5/16 sleeve here, and then with the extra length I wanted something that was going to kind of support all that and keep it tight. So I made the extra long sleeve, which is acting as a washer also. The cutter will end up inside of here, if that was the right cutter, and then it would get clamped in and held that way. The other thing I did is I wanted that end to protrude out through here a little bit so that I can run a center in there. This has been hardened and that works well, and just giving me a little extra support when I'm making this particular cutter. Same thing on when I'm making it, I'll use this arbor for making the cutters, plus it's going to be used for doing the actual cutting when it's all done. So we'll see how that works. This is a little different than what I've been using. I got high hopes for it. I'm pleased with that. What we'll show you in this in this video is taking a hunk of steel. Now I've got W1. I've been making the cutters out of W1 tool steel. And there's a, no, I justified it enough, but there's a reason why. I originally started with O1, and I was having real struggle with O1 tool steel, in that as slow as I was moving my form tool into the cutter blank, I was hardening the steel, work hardening the steel. And I tried everything. I tried making my form tool sharper, paying more attention to how I ground it, different speeds, using coolant, things like that, and I just couldn't get it. So if you got any suggestions. But I chose W1. It's pretty versatile. It's easy to heat treat compared to some of the other steels out there, which I'm really not that schooled in. Heat treating can be very critical, and I just decided to go with the W1. There may be other better things out there, and maybe as I keep going I'll figure that out. But we'll go from this blank hunk of steel to making blanks. Here's the beginning of a blank, and I'm going to show you how I do that, to actually ending up with a cutter. Now, one little thing I did, I don't know if this little trick is on YouTube or not, but my through hole on the headstock of my biggest lathe, this won't fit through. So I bought a 3-foot length of this W1, and I have to cut it in order to be fairly accurate in putting it on my lathe and making these blanks. So I'm terrible at parting off tool steel in the lathe. I can part things off, but I'm really bad at it, and it takes me forever. So what I'm doing is I'm chucking up a short piece in the lathe. I'll face it off. I'll take it out to my bandsaw and cut it, and then I'll take the cut side and I'll face that off. Now the problem with all that is I end up with this short little piece trying to hold it in my horizontal bandsaw. So I made, I don't know if you guys do this or not, but I took a piece of pipe and made a holder. So this this holder, my stock will just slip in here, even if it's a short little piece. Now I haven't even tried this yet, but we're going to find out if it works here in a little bit. And tighten those little set screws down, and that way it'll hold that steady, and then I have this whole length here that can be clamped into the vise on my horizontal bandsaw. So that makes life a little easier for me. The only thing is the direction of force when I'm cutting, and I don't know if it's a big deal, but we got a little gap over here. I could put all different sizes in here, I imagine. With this being here, I think the force I'm going to want to be going into this side, so my bandsaw will run this way, horizontally across there, and I'll just set this up. I'll probably tip it just a little bit so we got a little downward plus pressure going that way, and we'll just leave this gap side over here. That might work, might not make a difference. We'll try it. Over here at the lathe, chuck this up, collet here, sticking out a little bit. That should be okay. Now you notice I have a setting this up a little goofy here. Looks like oh, that'll be alright. A little bit of a radius on the tip of this, which gives me a nice smooth finish. So we'll just get going on facing this off. Looks pretty good. Okay, very nice. We'll go over to the bandsaw and cut that off. Alright, over here at the bandsaw, I'm not worrying a lot about exact thickness. Varying thicknesses, that's okay. That's why I made my arbor the way I did, so I can put in different thickness blanks. Also, when we're truing it up, getting ready to do the form, we're going to take some of that material off anyway. So we just want to get an approximate size. I think that'll be fine. It's about 3/16. There's our cut side. Okay. Alrighty, I switched over to the 3-jaw chuck here. There's a reason I'm using that. It's got a pretty good jaw all the way out towards the edge here, and I'm going to be setting it up with this adjustable parallel. And I've set it up to fit in there at just the right height, so I can clamp it. Oh, that'd be right here. So I'm just clamping it
Well, I didn't want to do that, but stick that in there again. Got enough on there, I think. Snug it up. Tap it a little bit. And then hopefully, you always want to make sure you get this out of there. That should be good. That should be it. There. Now, what I'm going to do, instead of leaving it way out, what I should have done is taken that out of there, is push it all the way in, flat to the jaw, or the chuck. And then I'll clamp it in. My chuck, and then I'm just going to put a mark on my blank, so when I flip it over, I'll put it in about the same spot. Drill the hole. I'm going to drill it to what I figured, what is it? 19/64, which is one drill bit size under 5/16. So I'll drill it 19/64. Then I will ream it at 5/16 minus, which is what does it say on here? 0.3115. I'm gonna see how that fits on my arbor. If it's too tight, then I'll go to a 5/16 straight up. After that, I'm gonna chamfer in on each side. Let me show you why. I have my cutter blank like this with a hole through it. We got all that bearing surface on the sleeve, which could be, you know, if it's off a little bit, then it's going to just cause problems. So we're going to get rid of problems by putting a chamfer in on each side. Well, yeah, in here and in here. Now we're not coming to a point. It's going to end up with a little bit of flat surface, and then like that, a little bit of flat, chamfer out. Chamfer doesn't have to be anything special. What we're concerned about is getting rid of most of that surface area here and here, which can cause issues, and just having a bearing surface on our sleeve right in the middle, or close to the middle. I mean, if it's not perfect, it'll be okay. Keep it from wobbling or whatever. So that's what we're going to do. Let's see if we can do it. Now for reaming, you want to go real slow. So I'm just going to put it in back gear real quick. Okay. Good fluid on there. And then just to push it through, and then stop the machine once it's through, and then pull it out. Okay, hey, I like that. It's maybe just a little snug. But I think I'm going to leave it like that and chamfer that hole. And that might just be perfect. Okay. See if you can see this in there. See that little flat in there? It's just right. That gets rid of most of your material in there, so it sits on here better. Let's see. So, and it's kind of a snap fit. What's going to happen is usually when I heat treat this, they feel like they get a little bit looser. So I'm going to leave it, and we're going to have to just hope for the best. Okay. All this material here, a lot of this can go away once I determine my minimum cutter width. I can take, when I get it on my other lathe, I can take and take some of that material off. And then it's also going to get trued up right across the outer edge here. That'll get cleaned up and trued up according to how it mounts and sits in the lathe. Alright, and then one more thing I'm going to do, just to make sure everything lines up right. It might be unnecessary. So I've got two dimples on these two pieces, so when I put them together, I'm going to always put them together like that. Then I'm also going to put a dimple on my cutter blank, and then that particular dimple, I mean, it could go in that way or that way, but it will be in the same area. Let's see. So I'm gonna guess about how far out I want to be. There. So every time this cutter gets put on this arbor, it'll be lined up. Everything will be lined up. Might not matter, but you never know. Okay, and that is tight. It's pretty snug, but I can get it on there. I almost like that. Debating about that. We're going to see what happens after I make the cutter. I'm going to have to take it off of here then when I'm finally done and heat treat it. So, like I said earlier, but if you didn't catch that, what I'm finding in heat treating some of this sometimes is it feels like the hole gets a little bigger or something changes just that little bit. It's not supposed to, I don't think, but that's what it feels like. So if it's just that little bit of a difference between 5/16 minus to 5/16, then that might be just enough. So we'll see how that turns out. Alright, stay tuned. This is the beginning of a series of 4 or 5 videos. I'll figure that out here shortly. And we'll get into more detail on how to do the whole job. Thank you. Have a good day.